Howdy folks, happy Thursday, hope you're doing alright. Yeah, that was a fun track, I like that one. Alrighty, got a couple things today. Let's see, okay. I think I dropped a couple frames, but we're back to stable again. It's been pretty good. I had some problems with my OBS software that does this broadcasting. Some of the settings got changed on it, and I don't know how, but I fixed them, so I think it should be a little more stable again here. We'll look and see. So we're moving on to chapter 3 today, all about relational databases and MySQL. We're technically not really using MySQL, but like a variety of it. So again, we don't really care too much. They're essentially the same. It has its own history, which is pretty cool to look at. And we don't actually do a lot with PHP today. We're going to save all of that for chapter 4, which is next week, how we use PHP and MySQL databases. We've got the lab that was due just before class started, and project 1 is coming up due next week. Hopefully you've had a chance to at least start that one. As a couple of people found out, I've been trying a little bit here, but Thursdays are a busy day of mine. I've got 3 different classes on Thursday. So it's really difficult for me to do much to help you folks on Thursdays. So class time now, and then the lab portion of class. So I'll again I aim to talk for about half or so, maybe 2/3 or so of the class, and then turn it over to you folks to actually start trying these things as if we were in our computer lab where I could walk around. I'll just go around and do screen sharing sessions, or we can hop on calls and Zoom or Discord screen shares and go from there. That's a good time to help. Other than that, throughout the week, I've got a little bit of time on Monday, and then a little bit of time all Wednesday afternoon are my dedicated office hours. And then I know you folks are busy people, and this is a night class. You might not be available during then, so I try and be available if we need to meet usually later in the evenings. I've never had anyone ask to meet really early in the morning. It's a possibility maybe. So if you can't meet during my regular office hours, right, reach out to me, suggest a couple times, and I'll do what I can to make it work. Generally, after my kids are in bed, 9:30. It's getting later and later now, which is weird. I feel like it shouldn't, but sometimes 10 or so. After that, it's a little quieter on the house, and usually I can hop on a call with somebody. So let me know. I'm happy to do what I can to help. But again, if you wait till Thursdays, like the day that something's due, I have got very limited availability to help with that. So just keep that in your back pocket. So we've got our lab we're working on. I'll go over that first, and then we'll get into the new stuff here. Does that sound okay? Let me fire up XAMPP and make sure that my PHP Apache server is on. All right, KB the Wicked, thank you. Hey, you're the first chatter here in stream. You should get some bonus points. Have 100 of them. So I think if you do exclamation bonus points there in chat, I want to say, I think it's bonus points. We'll tell you what you won there. I'm going to start up Apache. Let's see, does it work? Does bonus point work? Bonus points. Yeah, there we go. Oh, I'm sorry, I did it first. There must be a little bit of a delay here. I thought I fixed that delay setting, but apparently it's still a little bit delayed. Yeah, Nightbot will give you bonus points, but they're not actually worth anything. Where... There's a setting in here, I thought, for some sort of delay. Yeah, there's no delay set. Set to automatically reconnect. Yeah, so I don't know. I'm not sure. That's okay. Probably won't be too bad. I think it was worse before I changed back to my hardware acceleration. So before I was using software for encoding instead of the graphics card, and I don't know why I was doing that. But let me fire up NetBeans here. It looks like someone in chat was trying to use VS Code, and you might have had a little bit of trouble, then you got it figured out. That's awesome. I'm looking at alternatives to NetBeans because it's irritating me. I mean, it works, but there's pluses and minuses. So for our Java classes, we're looking at a different IDE, and I would love to use the same one for everything, but I know that's not always the case. So one of the good ones from, who does those? I forget the name of the company right now, but their PHP development tool has to be licensed, which is a bummer because it's much easier if we can use free software. That way you folks can go download it at home. We can get educational licenses for it, but then it's really difficult to give those out to you folks to use at home versus then you'd have to use our virtual machines. And I know that's not always the ideal solution. So if we can find open source or free software, I think that's better. Second pot of coffee of the day. This is fantastic. Again, if you have not taken the database course before, this is going to be all new. We need to hit the highlights so that you understand what's happening. You don't necessarily need to know like all the details, but you need to know enough to kind of understand what we're doing and why we're doing it and how we're doing it. If you have taken 1200 before, this might be kind of boring tonight. I apologize. But it was not a listed prerequisite for the course. So we'll make sure we get everyone at least a level set amount of knowledge about databases and relational databases and MySQL. And then we'll start using them next week in PHP. And it's actually a lot of fun because like literally every application nowadays is backed by a database somewhere. So data is stored in databases everywhere, and everything that we interact with basically will store data in a database. So it's super useful to get used to learning how to use those. It's rare that websites are just purely static websites nowadays. And then there are some, that's still a case where, hey, this website just has information. I'm just showing you something here, and that's fine. But even then, you're probably being tracked, and all sorts of that tracking information is getting stored places. So we can pretty much say everything will be in a database. So lots of fun there. And I have this really cool Pez dispenser now. I'm super excited. This little, he's like a nutcracker guy, right? We'll let him talk. All right. NetBeans finally loaded here. Okay, awesome. So let's start up a new project. And we go grab that assignment definition here. So lab 1. Okay, cool. We got 20 people got it in. We've got a couple more people than that in the class, but that's okay. If you miss one, it's not going to be the end of the world. So definitely, if it's only partially done, still turn it in. I'm very generous with the partial points on labs, but the goal is this is your main practice here, right? So this was our little credit calculator here. So we're going to have 2 pages, right? Our index page of the form, and then our results page that does all the calculations, getting this stuff out, making sure we're doing our special characters on the text input, doing filter validates on the numeric values, and then we'll tell them how long it's going to take to complete their degree program. So many more semesters. Okay? Does that made sense for what we were working on in the lab? So I'm not going to use this lab 1 repo here because it generates private repositories. And if I put code in a private repository, you folks can't go see it. So when I do my lab here, I'm going to put it in the public repository for the course. All right, so this is going to be lab 1. and I want to make sure I put it inside of my repository folder. So all of our code, all the NetBeans stuff is going to go inside the repository so that Git can track it. So we need to find 2454 for winter. And then I'm going to actually put it inside of another folder because I want to keep my stuff organized. All of your Git repositories are going to be like, here's one for one lab, here's one for this lab, here's another for this lab, so they should all be separate. Because I'm sharing a single repository, I need to make sure I have projects inside of other folders from there. So I'm going to make another folder called Lab1 and put the Lab1 project inside of that, just to keep things organized for you folks. So there's only one repository that you folks need to go look at to find all the code examples. You don't want one repository per week. That'd be crazy. Now we're going to say, okay, where is this going to go on the local site? Now remember, my Apache server, again, for my installation, I'm using port 5080. If you're running a port 80, fantastic. You don't have to change anything here. But I need to say, hey, it's localhost : 5080 for the port number /lab1. And then I also now need to make sure I'm copying the files from the sources folder to my htdocs folder here. And then the name of the folder needs to match this part of the URL. Right? Anything that's inside of htdocs, a folder becomes a slash in the URL. So I'll call this /lab1. So I'm going to say, okay, copy them to a lab1 folder here, and then I can find it at the URL /lab1. We'll go next, and we don't need any frameworks, we don't need any composers, we're good to finish. Now, someone messaged me, they were not getting PHP files created when they start a project. If it doesn't generate PHP files, don't worry about it. We can go add them ourselves manually. So all that information, KB, is in the project properties. So I'm going to close these ones down here. Get rid of some of this crap. So if you right-click the project over here in your project tree view, you can go to the properties on it. And then there's two places where it is. It's in the sources, has the copy location, and then the run configuration has the URL. It's not on the same page like it used to be, which is super weird. So sources is where you'll tell it, hey, you want to copy from your GitHub directory to htdocs here. And then the run configuration is where we say, okay, go to use this URL when you launch, please. Excuse me. So those are the two settings we're going to look at after the fact. Yeah, definitely. So if you, NetBeans, once it knows where PHP is installed through XAMPP, it wants to put projects inside that htdocs folder, which is it's just a bad practice. NetBeans also generates other files that don't need to be out on the web server. Right? We want to keep all of the NetBeans project stuff separate from that, so that just our PHP files make it out to that htdocs folder. We don't want anything else out there. Now, again, all sorts of other things, and take a web server administration class, and there's ways you can hide sorts of things and add a little security, but it's a bad practice to put stuff directly in htdocs. So we're going to copy from our NetBeans repository, or the Git repository that NetBeans is using, to the htdocs folder, just the PHP files that we want. Yeah, so if you're having trouble, let me know. I can definitely hop on a screen share with you folks and get you straightened out here. But okay, so we got that. And then I'm just going to give it a quick little run here. I'm just going to put a title. Let's just put the title in of like Lab1. I'm just going to hit run and see if I can get it to respond. So this will know that I got everything set up right before I get too far into it. So it finds Lab1, it automatically goes to the index page, and I get the title of Lab1. There was no contents yet, but we could echo here if we wanted, right? We could echo Lab1, and then if we, now you can hit run again if you want, perfectly fine, it's not going to hurt anything, or you can just come back to your page and refresh it. So once you save the PHP file, it's automatically doing that copying. NetBeans is actually pretty smart about that. That's one good thing in its favor. So just hitting refresh here is going to reload the page. If you hit run every time, there's nothing wrong with it, but you're going to end up with a gazillion tabs. Like you'll have 50 different tabs. Every time you hit run, it'll make a new tab here. And again, not the worst thing in the world, but if you just want to come back and hit refresh, you're fine there. Okay, and I'm going to take out some of these comments because I don't really care too much. So this is Lab1. Now in the index file, we don't actually need any PHP code. Right? All we're going to do is put a form in here for them to enter their information and then submit to the next page. And again, I'm kind of lazy and I don't actually remember a lot of the HTML stuff. I have to go look it up every time. So I'm just going to go find our form from last time. Oh, not the fall. What am I doing here? I want winter. Come on, URLs. There we go. So if we go look at our week 2 example here, I think in our index page, we had a form. So I'm just going to grab one of these forms and copy paste it. So I'll grab all of that, throw a form in here, and then I can change the things that I need to. So that form, the action here is going to go, what do we say, result.php. We could get or we could post. Again, I don't care which one you do. For our purposes here, it doesn't really matter. I think get's probably more appropriate. Right? The difference between the two, a get should be, it's a read-only sort of action, and it's okay to be repeatable, and it's okay if people copy that URL. Where a post is, if it's changing something, right? If it's taking an action, it's definitely more appropriate for a post. If you need to pass large amounts of data, you're going to have to do it in a post. You can only put so much stuff in a GET request. Or if you want people not to be able to copy and paste around a bookmark or a URL or bookmark a particular location and relaunch a certain thing, you might want to use a post. But I think GET should be fine. So we've got name, we've got major, and then credits required, total number of credits completed, and average credits taken per semester. So we have name, we have major, we'll leave major there. We've got then inputs for total credits required for degree. And then this will be, total credits. And then we'll have credits completed, and then the name should be credits completed, and then we'll do one more for average credits per semester. So there's one more label in here. This is average credits taken per semester. And this will be, credits per semester. And then we'll submit our form here. Okay, and I'm just going to do a format that's a source format, or Alt-Shift-F will take care of all the tabbing for you. So if some stuff is tabbed in weird places, or other things are over here, and you got some other whatever around here, give it a format. It's going to align everything for you really nicely. You don't need to do any of that by hand. We're going to let the tool do that work for us, right? You want to be like any good developer and be lazy, right? I'm going to say it so often you're going to get sick of it, but you want to be efficiently lazy, right? Don't do work you don't need to do, right? If the tool knows how to do it, let the tool do it. Okay, I think that tackles our form here then. Excuse me. Right. Then we need to send this out to the result.php page, display the number of semesters remaining for them along with their name and major. Right, doing our filter validate, HTML special characters. Cool. So let's go to source files and we'll go add a new PHP file. Let's add a new, what do we say? This is results.php, or just results, and it'll tell you it's a PHP. Should be fine. PHP file. Okay, and then again, I'm just going to go copy paste a bunch of things because I don't want to have to retype it all. So on one of these here, we had some validates. I want one of them that had, I think it was pizza. There we go. This one did some validates here with special characters. Okay. Oh, a dad joke. You got it. I've got a whole pack of them here for you. Thanks for coming along, me Marchie. Good to see you again. Hope you're doing well. How do you organize a space party? You plan it. All right, I think I told that one already. All right, that was a freebie. Here we go. What's the world's saddest pizza? Pepperlonely. These are so bad they're good, right? I think that's the goal of a dad joke. You want it to be so terrible that you groan. I don't know if it's a good joke if you actually laugh at it or not. All right. There we go. I also have a pack of knock-knock jokes if you are so bored. And again, this is a long class period, right? For us to be here for 2.5, 3 hours while I'm talking, we're going to get bored. So if you need a minute for a little bit of nonsense, a little bit of funny here, definitely feel free to redeem those. So happy to have a little break in the intensity here. All right. So we're going to have name and major then as our two variables first. And we want to do our HTML special characters to make sure we don't get any sort of junk, right, from the users. Any of that like embedded JavaScript or other nonsense that they put in there. So we'll have name and major. Name and major. Now, I used a get, so I'm making sure that when I filter validate is looking at gets here. That's good. And then we're going to have, what is it, total credits. And then we're going to have a credits completed. And then we copy that line again. And this was a average credits. Or was it credits per semester? What do we call it here? Credits per semester. Now, the names don't have to match. I just like them to match because I think that will make life easier for us if everything matches conceptually. There's no requirements. Like your variable name in PHP does not have to match the variable name here. It's just kind of makes life a little bit easier. And then like these copy paste, you can copy paste and then take out your $sign. And life is pretty good here. Now, someone had ran into, and I'm glad they asked the question, they kept getting zeros. And if your filter validate doesn't get the value, it's going to default it to a 0. That's one of the benefits of using these filter inputs here, is that it'll give you a 0 if it doesn't exist. Remember when we looked last week, if there was no variable and we tried to use it or get it, we would get those ugly PHP errors. I mean, we don't want to show ugly errors. But sometimes the ugly errors are nice because you know there was an error. Otherwise, you know, just it kind of silently gives you zeros and you're like, oh, 0. So, you know, it kind of depends. And, you know, we haven't actually gotten to debugging yet. And the weird thing is we're not going to get to that for 2 more weeks. It's a little bit complex to set it all up. And if we tried to do it at the very start, it feels a little overwhelming. So we'll just get into some general PHP first, and we'll actually do some databases first, and then we'll go from there. The validation is also the declaration. Yeah, so we're declaring the variable and assigning it a value of whatever I get back from my filter input function. So filter input says, if it exists, great, try and turn it into an integer. If it turns into an integer, great. If it can't turn into an integer, you get 0. If it can't find it, you also get 0. So you get some defaults here. Okay. Then we wanted to make sure we could, excuse me, calculate now the semesters remaining. So we need the total, or I don't know what, credits missing, maybe? Could be total credits minus credits completed. Credits completed. Again, you don't necessarily have to do this as a separate step. I just, you know, how about remaining? Remaining is probably a better word than missing. I like doing them all as separate steps. Sometimes I do them on one line, sometimes I don't, you know, sure. So we have semesters remaining is going to equal my credits remaining. Credits remaining divided by the credits per semester. Right? The number that you have left. So if you have 62 total and you've done 17 of them, you're going to have 45 left. And if you take 15 per semester, right? 15 goes into 45 3 times. Nice and easy. Now, we also had some issues here, right? If we want integer division, because we want whole numbers here, like when we did our rounding here, we'll do that same kind of idea. We can do integer division to get an integer result. So I don't want to just straight do this arithmetic, because then it'll say like half a semester. And you can't take half a semester's worth of classes. Now you could also look up, there's ways to do rounding in PHP. Like we just go Google PHP rounding up, see what we get. There's a round function. Seal would round up. So maybe that's even faster. But the things that we've looked at from last week here, we can do integer division, and then we can see if there's a remainder. We can say, hey, if my credits remaining modulus my credits per semester is greater than 0, right? We were going to take the semesters remaining and add 1 to it, right? So we could say, okay, just do the integer result, get rid of the decimal place, and then, hey, if there's a remainder when we do the division, we'll add 1. Sure, I guess doing the seal is probably even easier too. So we could do the other route here. So this is semesters remaining faster is use the seal function, seal, given the credits remaining. Why is it not typing that? Divided by credits per semester. Right, and that needs a semicolon. So either way is perfectly fine. Like this is the example we looked through last week. Well, so if you use the round function, you did it wrong, because rounding will round like rounding does. So if you're at 3.4 semesters, rounding would round to 3. And you're not done in 3 semesters if you need 3.4 semesters. Right? So it'd have to round up. It'd have to take the ceiling here, which is what this round does. You know, honestly, it'd be nice if you linked it here. It's one function, like it's not even one line of code that you're copying anything from. Like you literally just looked up, hey, there's this thing called seal. I'm perfectly fine with you not saying anything about it. I don't think that's anything you need to cite. But like if you found an entire formula, like going through a bunch of different steps, doing a bunch of things, then I'd want a citation. But like just the name of a function, no, that's perfectly fine. So no big deal there. Okay, so this is like the slow way, but again, that's what we looked at. This is the faster way. Sure, if you found it, cool, because you Googled. If not, that's okay. They both get the job done. No big deal. So now we have all the information we need, right? So we can end our PHP block. Now we can start writing some HTML code again, right? So again, I'm just going to go back and slap some HTML code around here. Just go grab all of that. Round doesn't work because like 3.4 rounded rounds to 3. If you need 3.4 semesters, you are not done in 3 semesters. No, you don't have to cite anything I say. I'm assuming it came from me. Yep. Yeah, or really anything from the book either, because the book is your main reference. I'm giving examples, that's fine. If you're taking like an entire chunk of my code, like letter for letter, then yeah, we should do something here. But if you're using a filter input, again, that's just a function. There's no citation needed here. Like there's nothing needed. Yep. All right, so then we'll have, we're going to say the name, right? We're going to echo their name. Hey, thanks so much for following along. Name. And then what we're going to say, you have, and then another echo, PHP echo, semesters remaining. This is getting a little long here, sorry. You have semesters remaining in your PHP echo. Now, again, this is kind of ugly here, right? So a better way, right, of doing this, instead of doing a bunch of echoes with a bunch of other HTML here, remember we can echo in a single quote here. We can do the double quoted string and get substitutions here. So it'll automatically substitute for us. Semesters remaining semesters in your, and again, this is a little long here. That's fine. We can just bring it down a line. And it'll automatically add in that concatenation is the dollar, or I'm sorry, the period is for string concatenation major. And then a link, if we want to go back to index, sure, we don't really care. I don't know, go back or something. Why not? I copy pasted it, so might as well. So remember, this is going to be a little easier here to do a single quoted string with the automatic variable substitution rather than echo more HTML, echo more HTML, echo more HTML. It gets a little funky. So this ought to be it for it then. We'll give it a save, come back here to lab 1, hit refresh, see what we get. So you have Eric, we have the engineering, automotive systems and mobility. It's, oh my goodness, why I should really know this. It's like 45 or something, and I literally have 3. And I don't go very fast, so maybe it's only 30. Maybe it's only 30. I take like 3 per semester. So 30 minus 3 would be 27, divided by 3 should be 9 semesters left. So let's make that like 32, so it should round up, right? So 32 minus 3 should be 29 left. 29 divided by 3 should be 9, rounded up to 10. We'll submit. Oh goodness, it didn't, result.php, we have results.php. So it doesn't find the page because we didn't send it to the right page. Either change the name of your PHP file or send it to the right location here. Let's go back, refresh, make sure I saved that. Refresh. Eric, sure, it's saved there. 32, 3, and 3. Submit. All right, I have 10 semesters remaining. Fantastic, and I can go back. That sound okay? That's what we had for lab. Questions, thoughts, concerns? Let me get that committed here. That's the plan. Generally, I'm going to go over the labs for you folks, just to see if there's anything you might have missed, any questions you might have. We should be able to get those done relatively quickly at the start here. We go to 2454. And here's lab 1. So again, it's in the GitHub repository folder, so we can commit all the changes here. And these are the NetBeans projects. We don't want these files out there. We don't need them here. We just need our PHP one here, which is cool. So we don't need any of those other properties and whatnot. And it's ignoring the private folder. There's a bunch of private stuff that gets ignored, which is nice. Okay, so we'll commit lab 1, and then we'll push. We're going to synchronize to the cloud. GitHub.com will have it. And then if you want to do a quick sanity check, go to repository, show in Explorer. Or I'm sorry, view on GitHub. Repository view on GitHub. We'll see if we can see it out in the cloud. There should be a folder for lab 1. Zoom that back out a little bit. Lab 1, and I see my index and my result pages. They look like they've got the right stuff in it. Life is good. Okay? How you folks feeling so far? You doing okay? All right, awesome. Yeah, we're getting moving here. So today again is a little bit funky because we're gonna do all database stuff. Yeah, GitHub command line. Yeah, you could do Git from the command line if you want, but I think the GitHub desktop client is actually relatively decent. And then any IDE, any language, they all basically work the same with it. So no, it's okay. The small issues happen all the time, KB. That's literally all the time. So my class earlier today was my Python class, and on Tuesday I was supposed to be demoing something, and it just would not work. And it would not work, and it would not work. And we ran like 15 minutes over, and I couldn't get it to work. And then like right at the end, I was like, oh wait, I think I know how to fix it. I left myself a note, and then we ended class a little late. And then this afternoon, we went and fixed it. It was like 3 lines of code that I had to change to fix the whole thing. And I spent like 15 minutes, maybe even like 20 minutes on Tuesday trying to figure out what it was. It was 3 lines of code. So that stuff happens all the time. Just part of the process. Excuse me. All right, so don't forget Project Zero. Cool, I got a couple submissions of that already. Fantastic. Get that done and out of the way. Remember, labs only make up a real small part of your grade here. The projects are the main portion of the grade here. With the labs, I'm generally going to be like talking you through them, giving you lots of hints, that sort of thing. We would have walked around in class, and generally, if you wanted to finish it, you would have finished it before you walked out the door in class. If you had enough and you just wanted to go home and take a break because it's too long to sit there and you were, whatever, that's okay. We can get it done throughout the week, no big deal. But those were designed so that more of a participation points. Hey, Junkyard, thanks so much for following. Yeah, so more participation points for that. The project's a little bit more open-ended, a little more vague. I don't necessarily give you quite as many directions. It's like specifically what it should look like or how you're going to go about it here. A little more up to you. Where did that go? Here are right in here. So like the labs only make up 10% overall. So we'll have the lab every week, but they don't make up a large portion of your grade. So focus for sure on the project. If you have limited time, that makes up 30% of your overall grade. So the 4 projects we're going to tackle, individual projects, right, make up 30% of your score rather than the weekly labs making up smaller amounts here. We've got the quizzes, so don't forget we got the quiz on chapters 1 and 2 coming up due tonight. That'll post the quiz on chapter 3 as well. So every time we cover a chapter, we'll have a quiz on it. We do that next week. So keep that in mind. Apparently, D2L's decent at telling you when quizzes are due, but not so good at telling you when assignments are due. So like your update section is going to tell you like you've got an unsubmitted quiz. Apparently, it doesn't tell you that you have an unsubmitted assignment, which I'm a little confused by. But, we can go from there. Oh, I'm going to need some more coffee soon. My goodness. This mug is almost empty. All right, so all about SQL. Now, I'm actually going to spend a little bit of time drawing here because this is a little bit more conceptual. So you might be familiar with files, right? Files are pretty basic, right? In your intro to coding class that was a prereq, you probably worked with text-based files. a coffee break redemption, I just have the emote, me Marchie. I got the jitters one, which I love. It's like a little animated one, or I got the regular coffee emote here. If I drink too much coffee, though, we're going to have to take more breaks. It won't just be coffee breaks. All right, so we worked with files, right? And you can store information in files, right? So if we wanted to have some sort of like store inventory, right? So say I was going to sell coffee, and I would say, hey, maybe I'll sell the coffee for $1. I could do that, and then maybe I'll have tea, and maybe I'll sell the tea for, I don't know, 50 cents. And then maybe we have Coke Zero, and maybe we sell the Coke Zero for $1.99. Right? And anything else we want to add in our store, we could list out in a file. That's workable, it's doable, but it has issues, right? And then other things we probably want to know is like what quantity we have. So maybe I'm going to have like 20 coffees that I can sell, maybe I'm going to have like 30 teas that I can sell, maybe I only have a dozen Cokes left at my store. It's like we've got all these pieces of information just jammed into a file here. So we have to essentially read the entire file. A limited time offer. Look at that. Thank you, Microsoft, for advertising right inside my program. We'd have to open up the file, read the entire file, and go from there, which is fine for like my small little store here because I sell coffee, tea, and Coke. Right? There's not anything else going on. But imagine you're like any sort of decent-sized store. You literally have hundreds, if not thousands, of items. Like even a gas station, they probably have at least 1,000 items for sale, I'm going to guess. Between all the different beverages, all the different snacks and candies, it's got to be in the thousands, right? Of all the different barcodes or what are they called? SKUs? Is that how they count different products on the floor? So you'd have to open it up, read through it, 1,000 different items here, and then you only have one copy of this file. So if you want to have 2 registers open, how are you going to go through and be updating the quantity in a single file? So hopefully real quick you get the idea that storing stuff in a file is not all that practical. Right? We need a better solution for storing data in a way that can be shared among multiple devices. Right? And that's what databases are for. Databases are made for storing information and then making it accessible to multiple users. They're really good at that sort of thing. So relational database management systems, or this RDBMS, so relational database management systems, right? RDBMS. That B is a kind of funky looking there, sorry. Their job is to store information, and we're generally a big fan of this relational portion here. You can make database management systems that are not relational, but essentially relational is still the main way that we're storing data. There are newer systems. Some of the big data systems are not necessarily relational, but they have their own sets of interesting quirks and things and characteristics that go about big data that probably don't make a whole lot of sense until you've talked about relational database management systems. So generally when we talk about databases and we teach database technology and concepts, we start with relational database management systems, and then you can move up into those big data systems, or the NoSQL, which is not actually, it does not mean no. When you say like a NoSQL database, this is not the word no. It means not only SQL. So an SQL or SQL here is the language that you use to talk to databases. So this SQL. Everyone I know pronounces it SQL. SQL. It's not. I'm pretty sure that's how we pronounce it. That's what I've always heard, but we also here in Michigan we call things pop, and across basically everywhere else in the world they call it soda. So, your mileage might vary here, but I've always heard it as SQL. Yep. So, SQL is the language in which we use to talk to databases. Now, with SQL, there are essentially 2 types of SQL here. Don't worry too much about it here. Yeah, for some reason, some people in the South think everything is Coke. And they ask, what kind of Coke? And you're like, Coke, like Coca-Cola. But, so, I don't know. People are weird. We have all sorts of interesting regional things, so I think that's kind of fun. So the 2 types of SQL here. You live in the South, and okay. So who calls everything Coke? I thought that was a Southern thing. Do we just make fun of them for it and they don't actually do it anymore? So you have DDL, and you have DML. So DDL is data definition language. DML is the data manipulation language. We're going to focus almost exclusively on the DML. DDL has its own whole sets of things. Don't worry too much about it here. We're going to do a couple things. We're going to use some tools that do the DDL for us. So we have tools that essentially automate this for us, and it's amazing. Okay, the DML we sort of have to do by hand. This is what we're going to focus on. So we like the DML. So this is for manipulating data in the database. Data definition is for defining data in the database. So one of the characteristics of a database, let me see if I can go to a new page here, is that we have a very tightly controlled way of defining what is stored, where it's stored, and how it's stored. And it fits relatively well. So I think all of you came from a Java background. And in Java, you say, hey, I want a variable, and it is a type of string. Or I want a variable, it is a type of int. Right? So we do that in Java. We have int, right? We have double. We have string. And again, you've got your specialty types. You've got chars, and you've got booleans, and you've got byte, and all sorts of other fun things here. But essentially, we like ints, we like doubles, and we like strings. Those are our pretty common ones. But you have to tell the computer what type you're using. So it's strongly typed. In PHP, it's kind of a crapshoot, right? We said, hey, please give me a variable here, and it should be an integer because filter input will give me an integer here. But before we were using that, if we were just getting stuff out of like the gets here, we hoped it was the right thing. And PHP does this, they call it duck typing. If it looks like a duck and sounds like a duck, it probably is a duck. So if it looks like an int, sounds like an int, or acts like an int, it's probably an int. So it's loosely typed. So, but back to databases here, in our data definition language, it's the same idea. We say, hey, this particular field, I'm going to say maybe your name is, now we don't have the type string. You've got actually lots of different types, and there's lots of different reasons for things in the database land. Take a database class. We're going to call everything a varchar for strings. So varchar is short for variable number of characters. And then you can tell it the maximum size. So varchar, you could say 100 means no more than 100 characters. Again, don't worry too much about it. We're going to use the tool to automate it here. But generally, instead of strings, we use varchars. Okay, we still have ints. Generally we use a decimal type for doubles here, essentially that. And then we still have ints. So ints are the same, whole numbers, they work the same way. Decimals for doubles, and you get to define a couple extra things like how many decimal points you want, and you get to be kind of specific here, and then varchars. But the data definition language says, hey, I'm going to make a table. Now, I used to think most people were kind of familiar with Excel. I don't know if that's true anymore or not, but remember Excel gives you like essentially a grid here, and you get rows and columns. And in each row then we say, hey, this is what the row is. So maybe I'd say this is the name, and this is the cost, and this is the quantity. And I don't know what this other column is. I don't have a use for it right now. I drew too many. Right? So this is sort of the format here. We get rows and columns. So each column then is defined by the DDL. And we say, hey, this is a varchar. We say cost is a decimal. There's actually a money format, but decimal is probably easier for now. And quantity is probably an integer. You probably only have whole numbers of things. Again, if you're doing stuff by the pound or other weird sort of things, it's going to be different. But for our store, it's simple. Like one item has one barcode on it, we'll call it one thing. If I've got 10 of those things, I've got 10 items with the same barcode, right? So we'll have quantity. So we define what's in the table, and then each row in the table then makes up an instance or a single entry of this given type. So this table then gets a name. We say this is the item table. So item gets a name, right? So we get to have coffee in here. And then the cost was, what do we say, $1 for coffee. And we had, 20 coffees or something. Then we had tea. Tea was like 50 cents or something. And we had 10 teas in there. And then we had Coke Zero was $1.99. And we had a dozen of those or something. Right, so each row in the table represents essentially an instance of that type. So this is one item. So I put all the columns together here in a row, and I have all the information about one of the type in this table. Right? So I can have my tea, I can have my Coke, I can have my coffee, whatever it is. They all fit, right? And each column then defines what's inside of it and how it's defined, right? So the types belong in the columns here. And then all of those added together make up a single instance. There's a lot more to it than that, but that's essentially a quick table. Okay? Now the next thing that we have in database land, and this is very particular to database management systems, is that we really care about what's called data integrity. We want to make sure that we have good data. So one of the things that we're going to do in our table is we're going to define something as a key. So we use the term primary key. Primary key. And a primary key is the main unique identifier. Main unique ID for that particular entry. For an entry. So imagine we had a table like student, right? If we were storing student information here. Name is not going to be a good unique identifier here. No, it is for Eric Chernesky. I'm the only Eric Chernesky in the world, right? And that makes it easy to Google me, which is nice. If you have more of a common name, like my friend James Smith, there's a lot of James Smiths, right? There's tons of them. You can't Google and find this particular one very easily. It's kind of difficult unless you know more information. Right? So name does not make a good primary key because it's not going to be unique. Okay? So a lot of times, like what we do is we come up with another identifier, like, hey, all of you happen to have a student ID. Right? Your student ID is just a number. It's just a made-up number that we put in the system that uniquely identifies you. So that is the primary key that identifies that row in the table. So if I want to find that particular Eric Chernesky, I can look up my student ID. Right? If I want to find that particular James Smith, I'll find him by that student ID. And that will uniquely identify him. So then we can still have name, and then we can still have all sorts of like address and all that other info in here. You get all sorts of other good pieces of information. You can have tons of columns and tables. Tons and tons and tons and tons of columns. Like as many as you need here. Right? But the unique identifier, the primary key, will be the unique identifier for that entry. Okay? So at a store, it's probably fine for our name to be a unique identifier. Right? You're only going to sell one thing named coffee. Now, if you have multiple kinds, you're probably going to differentiate them like, hey, I will have decaf coffee, or I will have regular coffee, or I will have black coffee, or I will have dark roast coffee, or French roast coffee, or, I mean, anything you want to come up with here to differentiate if you want to be unique on name. Again, it's not actually the best unique identifier. Probably a better unique identifier here, we can use this other column now, might be that SKU, right? The SKU is the barcode, right? So the given whatever particular barcode here, that's the SKU for this can of lime Perrier. So this number here, 07478033352, I think an 8, is the unique identifier. Look at that. I actually read it off the screen there. So a SKU is probably a pretty good unique identifier for a particular product, right? Because that will definitely be the unique identifier. Right? So sure, whatever that is. So maybe the SKU then could be our primary key. A lot of times you can say PK for that, primary key. Okay? So we can track that sort of information with a primary key. So far we've just had tables, just a single table. We don't have any relationships yet here. So we do another page here. Now when we start relating things, now if you imagine shopping at a store, right, they're going to probably want to save all of the things that you've purchased in a single transaction, right, and give you a single receipt. And then your receipt will have some sort of like transaction ID on it. So they can go look it up later in case you want to go return something. Again, maybe at our store, we're not going to let you return coffee, but you can go return items to your Walmart or your Target or something, or your Meijer. That's fine. So we need to track all of that. So we have this idea of an items table here. So item table, other people call them entities, the item entity. Don't worry too much about the terminology for our purposes here. And we say, okay, sure. So SKU then, the SKU, was our primary key, and then we had everything else about the items here. So then we had customer, right? The customer table here, right, has some sort of unique identifier in it. So how do we identify them? It's probably just an ID field, and we probably just auto-generate these things. Like with your loyalty rewards, everyone gets an ID for everything everywhere because they love to be able to track what you buy and that sorts of things. And sure, if you don't sign up for it, then they have no idea who it is. But generally, we'll know who's buying these sorts of things, right? So it's customer, right, with all sorts of information here. Okay? So a customer is going to buy items, right? And an item can be bought by a customer. So when we talk about relationships here, this idea of a relational database management system is what's the relationship between, that's a question mark, not a 3. There we go. A item and a customer, right? Well, you want a customer to buy many items, right? That you want them to purchase a lot of things. And you want an item to be bought by lots of people, right? If only one person ever buys one thing, like that's kind of boring, right? You want everyone to come in and buy your coffee. So we'd say it's a many to many relationship here. Many customers will buy many items, and many items will be bought by many customers. You can't do a many to many relationship in a relational database management system. It doesn't work. Because where are we going to say for a given transaction who bought what? We can have a table in here. Sure, we can make a table for transaction. Okay, so a transaction then can just get a uniquely generated ID. Sure, transaction 1, 2, 3, 4, 5, whatever, however we want to do that, no problem. Don't worry about that. But now, how do we say what item then goes in this transaction? So like a customer will have many transactions, right? So a lot of times this notation used this crow's foot. So a single is like these 2 lines here to many transactions. So one customer will have many transactions, but for one given transaction, that will relate to one customer, which is nice. So we know what customer here, so we can have the customer ID as a field in my table here. So if I know, hey, this is customer ID 1 was Bob, customer ID 2 was Jim, customer ID 3 was Eric, I can say, okay, hey, for this given transaction, 2, 3, 4, whatever, customer ID number 2 bought something. So I can track back this relationship and say, okay, transaction by the primary key. So this customer ID field relates to the primary key in another table. So this gets a special term here. We call this a foreign key. It's a key that is foreign to my table. So the customer ID is a foreign key because it relates to and is a primary key in another table. So all I need to do is put their ID in here. I don't need to put all of their information, right? I can just say, hey, customer ID 2, and I know, hey, it's Jim, and this is his address, and this is his phone number, and this is yada, 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 all sorts of that good stuff here, right? We can look him up because we say, hey, this value matches a value over here. We say 2 is equal to Jim because 2 represents Jim here. Sure, we could do that. Now, how do we track item, though? If I can buy coffee and Coke and tea in one transaction, what am I going to do here? Am I going to put, hey, this was item 1 was coffee, 2 was tea, 3 was Coke, right? I can't even write here. This was coffee, right? What do I want to do? I can't put 1, 2, and 3 in here. Technically you could, but that's really, really, really bad. We don't want to do that sort of thing. So that violates good database design principles. So a single field should represent a single value, right? So you can't have multi-valued fields. You can't put multiple pieces of information in a single field. That's bad form. You could have like item 1, item 2, item 3, item yada yada, and like, but if someone wants to buy 100 things, like when I go to Meijer and I have to buy food for my 6 kids, I've got a lot of stuff in the cart. You don't want a table that has 100 different locations here because that's inefficient, right? The way stuff gets stored behind the scenes, if someone just buys one thing, you now have 99 blanks in your data because they just bought one thing. So it's an inefficient way to store things. Okay, so what we're going to do is we're going to, again, So we're going to solve this relationship, right? Because we want one item in many transactions, and a transaction should have many items. Right? So that's a many-to-many, so that's no good. So we need another table then that joins these together. They call it a bridging table or a joining table here. So we'll say this is a line item. Or transaction item, might even be easier, right? So how about a line item? Fine, line item here. And line item then will have its own ID, right? Every table gets its own primary key. There's a way to make the system generate these, which is fantastic. That's generally my favorite way to do things. If you've got something like a SKU, perfect, fantastic, that's great. If you've got something to uniquely identify people already in the system, awesome. But just for, hey, I'm just going to put a bunch of data in, I'm just going to let the system generate it. So we'll get an ID here for the line item, and then the line item will relate to the transaction ID. So the transaction ID is a foreign key. A lot of times we call that FK for foreign key. It relates to an ID over here. So, hey, this is for transaction 234, and then it has an item ID. Then item ID relates to one item over here. That's another foreign key over here. Okay, hey, I bought a coffee in this transaction, and then I can add another piece of information. I can add another row to this table and say, hey, same transaction number, I also bought a number 2 item. Hey, same transaction, I also bought a 3 or a 4. I could list 100 different rows in this table then, each one relating to one transaction and one item. So now what we get here, a transaction can have many line items, but a line item relates to one transaction, right? A item can be in many transactions, or many line items, but a line item relates to one item. So we take a many-to-many relationship and we stick a joining table in between them so that one item relates to many line items and one transaction relates to many line items. But that way we don't have the many-to-many here. So we took the many-to-many here and we said, no, we can't do that. We're going to fix it with the joining table. So we're going to do these joining tables all throughout here. So we need to resolve any sort of many-to-many relationships with the joining table. Again, you guys are new to databases, possibly. Maybe you've had the course before, that's fine. So I'm going to help you out with all the database stuff. So we're going to go over an example that we're going to use next week. We'll build out our database, and I'll build the first part of it, and then you guys will go finish it. And that's generally how I'll try and tackle stuff for database land projects, because I don't expect you to have a lot of this background, but we need to understand why stuff is designed the way it is, because otherwise it doesn't make any sense. Okay? So we're having our database here. We're using these foreign keys to reference other tables' primary keys. One of the things the database's job is to do is to ensure referential integrity. Okay? Referential integrity says if you put something in that I've defined as a foreign key, it must exist as a primary key. So a foreign key will always equal a primary key. If I try and put a transaction in and say, hey, this was for customer 37, and there is no customer 37, the database will puke on me and just says, hard stop, game over. You can't do that. The database's job is to make sure we have references where we said we should. So that's one of the things databases are good at. They're always checking this sort of thing for us to make sure we don't put bad data in by mistake. Like, can you imagine, hey, you're trying to enter a bill for somebody in your system and you put the customer ID in wrong? Now, no one's going to get the bill, and that's bad because now your company's not getting paid for it. So it prevents those sort of errors from happening because it ensures we have referential integrity that, hey, if you said it goes to this person, that person actually exists. Now, the other great thing about databases here, right, is that it helps reduce the redundancy of data. So if we go back to this like text file idea here, we could have a text file for transactions, right? Each one of these could be a file. We could have a file for customer, right? And then we could have all the customer. We could have their name and their phone number and their email and their address and yada, 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 whatever we wanted here, right? We could go do that. And then I'd have to go look it up. Doing it in individual files is annoying. So oftentimes then you would just repeat. So for a transaction, then we'd say, okay, hey, so-and-so bought the coffee, yada, yada, yada. And you're going to repeat this data over and over and over and over and over again for the same person. So if your customer calls and says, hey, by the way, can you update my email address? You'd have to update it every time you ever stored their email address. With the database table, you just have it stored in one location. You just say, oh, sure, let me go find you in the table here and update your email address, and boom, it's been updated. Because everything just references that where it exists. You don't have to make copies of data. So a lot of times we'll call it controlled redundancy, because there is a little bit of redundancy. Every time you have a foreign key, that's technically redundant data, because you're saying, hey, reference this thing over here, reference the primary key. So that's another good reason that integers or numbers, some sort of numeric values, make really good foreign keys instead of strings. Because strings are kind of long and complex and hard to store in databases and have all sorts of weird, funky things about it here. But integers are pretty easy. Right? We know integers store in 4 bytes. Don't take a lot of trouble here for integers. Right? So referencing an integer is not a lot of redundancy here. That's not so bad. So that's one of the things in databases. Oh my goodness, it's been an hour already, friends. I think we are due for a break. You guys think that's a good time for a break? We'll come back and talk more about databases. I know this is a lot of fun. Totally weird topic, but we need to understand the basics of why things are the way that they are before we can then go start using databases in PHP to write really interesting web applications. That make sense? I'm going to drink some coffee. There's been no chat for like 20 minutes, so I think you folks are all having a lot of fun. Okay, cool. So Ed Griff, have you had a database class before, or is this all brand new? Just curious, just for my own curiosity. All right, and there goes the coffee. It is gone. Okay, cool. So hopefully that is all review then. So, goat. Okay, cool. All right, so why don't we take 10? We can go get some coffee, use the bathroom, do whatever you got to do. We'll come back. We'll spend some more time talking about databases. We'll look at the tool that we're going to use then to build databases, which is really cool. It comes out of the box in XAMPP. It's fantastic. And we'll go from there, okay? We'll put the music back on, and we'll go from there. All right, so 10 minutes puts us out to 7:17, I think. 7:17 p.m. Right? All right. See you folks in 10. Howdy folks, welcome on back. Alright, man, this one's chill, I like this. Should I just leave that on in the background? Just like a nice little quiet, little chill music, or is that distracting? I don't know how well the sound, I don't know like what level it needs to be, so it's not too loud compared to the voice. I don't know, or we can just pause it, it doesn't really matter. Alright, so we've done essentially the basics here. There's a lot more to it. Don't worry too much. I think we've covered enough of the basics for now that I want to spend a little bit of time actually going out and playing with it here in our tools. So in XAMPP, one of the things that comes installed it's not actually MySQL, it's MariaDB. It's essentially the same thing. So if you just like Google it, MariaDB versus MySQL, it's pretty much the same, right? It's a fork of MySQL. So MySQL is an open source database language, but MariaDB is like they slightly diverged at one point, but it's essentially the full thing here. Excuse me. So they maintain the compatibility here. So it pretty much works between the two. All right, maybe that is a little distracting with music. I'm sorry. I'll just pause it. Okay. So we can go and hit start on MySQL, and this one should just work. Generally, this one's pretty good here. No need to change any ports or anything, and it should just go. Then what we get to do is you get this cool admin button, and you click on admin, and it's going to launch your browser out to localhost/PHPMyAdmin. Now, again, mine doesn't work because I forgot to change the port number, so that's :5080. If you're on port 80, it should just launch, and you'll get this default starting page here for PHPMyAdmin. We'll see if it loads for me here. I'm crossing my fingers. It was so good earlier. Might make for a short day. Now we'll get this going. Come on. Come on. Let's go. Oh, I don't need the Twitch page open. Maybe that's why it's going extra slow. And we can actually close down NetBeans now too. And I'll close this one out. There it goes. Okay, it's loading. It's just going a little slow here. Just the first load. That's okay. All right, so you should get a page that looks something like this, the PHPMyAdmin. So this is the PHP application written for managing the MySQL databases, so the MySQL administration. Lots of cool stuff happening in here. So you've got on the left here, these are all different databases. So another idea with database management systems is a single system can have multiple databases. Right? Lots of cool things can go around there. So we're actually going to build out a new database here. We're going to click on new. And if you want to follow along with this, great. If you want to follow along later, that's fine. But what we're going to do is we're going to use this database next week when we start actually writing PHP code that talks to the database. So the only lab for today is actually just going to be essentially following along and doing this same thing here to make sure that you have the same database. Because if your database is different than mine, my example code isn't going to work for you. And it's not the worst thing in the world. You can go tweak things if you need to, but it's usually easier if it works. So we're going to call this the store database. So the name of the database is just store. And again, generally I'm going to do everything in lowercase. It's occasionally case sensitive, so I'm going to try doing everything lowercase just to keep things consistent. That'll make life easy for all of us. So we'll call it store, and we'll create the database. Now it says no tables found in the database. So it takes us right to this page here, and you just click on the store database, and it'll show you, okay, we don't have any tables. So each database then is a collection of tables. So we can make tables. So it says, what's the name of the table? We'll call this the item table. And how many columns? Sure, 4 columns. You can always add more later, so 4 is probably enough for now. We're going to go out and build this database just like we did kind of with our examples here. So the type here, this type column, is what type of data is it here? And you got all sorts of cool options here. So ints, right, are common. Varchars are common for strings here again. There is a specific date format, but that's just a date. If you want a date and time, again, there's all sorts of different ones here. There's date times, and then there's timestamps. timestamps are ever so slightly different in that they use this Unix epoch format, which is the number of seconds since 1970 January 1st, UTC time. It's a whole thing. Don't worry too much about it here. So date times are generally a little bit more flexible, that they can store more future dates. Because we are going to run out of dates. So these timestamps only work out to 2038. You can't put anything further than that into the future, because the number of seconds between 1970 and 2038 is larger than an integer's worth of seconds, or something like that. I want to say that's right. Is it an int? It's probably an unsigned int, right? So 4 billion. What is 4 billion seconds? In years. Can we just convert that real quick? Here we go, 126 years. Is that what we had? 126 years? Does that sound right? No. No, that's less than 100. Maybe it's 2 billion seconds. 2 billion seconds. There we go, 63 years. Yeah, that one looks more correct, right? 63 years or so. Anyway, oh, Marv, sorry, it doesn't take links, so if you post it over in the Discord, that'll work well. So links get like auto-filtered out in Twitch chat just in case. Is it 68 years? Okay, so I don't actually know where all those are coming from exactly, but that's essentially the problem. So it actually stores it as a number of seconds, and eventually that field is going to run out of space. So, so ints, right? So what we're going to do here, so our primary key, then we said was going to be the SKU. So I'm going to put an SKU. I believe those are all integer values, right, for SKUs. I think, yeah, they're all numeric. Now the problem with that, though, is that sometimes they have a leading 0. We're just going to pretend that's not a problem. So in the real world, if you have a leading 0, you can't really put that in as an integer value. But again, probably not too big of a deal. So we'll just call it an int here. I'm going to scroll over a little bit further to the right. And then on this index dropdown, I'm going to come down and say primary. So if I mark it as the primary index, it's going to mark this as the primary key for me. You just click on go, and we're good to go here. So SKU for that, great. And then we'll have name. And then name, we're going to say probably a varchar here. And then with the varchar, excuse me, I have to sneeze. It is a good thing I'm at home and not sneezing all over you folks. Or sneezing into a mask is actually like one of the worst feelings. So I always have a spare, because, oh, that's just miserable. With the varchar, you have to tell it what is the maximum length of characters here. And I don't actually know. Some items have some really crazy names, so I'm just going to go like 200. For our purposes, we don't care. Oh, thanks so much, Marv. Appreciate it. When you start storing millions of things, then it's important to be more accurate. For our purposes, a little bit of extra length here is not going to make any difference at all. So I would rather go larger than needed than to have to come back and fix it later. Okay, so we had name, and then we were going to have the quantity, right, as an integer. Great, right, the number of items that we had, and then we were going to have price. Now, there's all sorts of different values here in these numeric values. There are doubles, and there's decimals. So doubles work the same way. Decimals give us a better precision, a fixed point, so maximum number of digits here, and a maximum number of decimals. So they work a little bit easier for us sometimes if I'm saying, hey, I only want 2 decimal places, or sometimes doubles get some weird arithmetic happening there. So I think we're fine either way. We can stick to doubles because it's probably easy. With decimals, you have to define how many. You know, what's the length of them. So I think we can just do double. We'll be okay. Again, for our purposes, it's perfectly fine. We're not doing database administration sort of stuff. So, you know, look at more of these types and the impacts of them later on. But we have the SKU, we have the name, we have the quantity, we have the price. Okay? We say save. Now, if you want, there's also the preview SQL button. I'm not too concerned about that, but you can go to is it SQL right here? I don't think this is it. That's not what I want. No, so that's not going to show us it. I'll do it for the next table. I forgot to click it, sorry. You can look at the DDL that is generated for this table. There's all sorts of really cool information in this tool. It's way more than we need here. Right, so we just made a table. Great. Now what we want to do, if you go to browse, you can actually see the data that's inside of it. Now there's nothing in it right now because we don't have any. So we can insert, if you want to insert some data. So okay, so it says, here's the column, here's the value. So we'll say SKU number 1 was going to be coffee. We had 20 coffees here, and the price was $1. And then you say go. Now, it says this is the SQL that runs here. So this is DML, data manipulation language. We'll get more into this later in a little while. Don't worry too much about it. And we'll talk more next week when we look at how PHP works with it. But what you do is you say, you use this insert keyword into the name of the table. And then you say, here are the fields that I'm going to insert in this order. So I'm going to give you a SKU, I'm going to give you a name, a quantity, and a price. And then you say values, and in the set of parentheses, we give them the values we're adding. So 1, coffee, 20, and 1. Right? And it goes and runs that. So now when I hit browse, I'll see I actually have some data here. I can see it right on this line. It's kind of a funny view here. The other way of viewing this data, they're showing you this is the SQL, so the data manipulation language here. A select is used to get information out of a database. So you can select to read the data, you can insert to create data, you can update to update data, and you can delete to delete data. So those are the main keywords. So a lot of times when we talk about working with data, we talk about CRUD, which is create, read, update, and delete, the CRUD operations. So we can do that in SQL. To create, you insert. To read, you select. To update, you update. And to delete, you delete. So there's a bunch of keywords. Again, I'll give you examples on all of them, just so don't stress too much about it. All we're going to need to do is tweak the names here. So this is the table name, right? So we can tweak the table name if we want to get information on other tables. So I'm going to go back to store, and we're going to add a new table. Right? So I'm going to make a new table. We'll call this one the customer table. 4 columns is probably fine. Again, we don't need to worry too much about it here. So for customers, I want to generate these IDs here. So I'm just going to call this field ID here. And what I'm going to do, if you scroll on over, there's this really cool box called AI. This is auto increment. What this says is, hey, database, you pick the number for me and start at 1 and just keep going up. Right? And for an integer value, right, you can get up to 2 billion or so. So there's no way 2 billion people are going to shop at my little pretend store here. So I'm fine with an integer. Now, if you're Amazon, you probably don't want integers for your customer IDs. Right? You need something bigger. But for us, integers are fine, right? We don't need to worry too much about it. So I'm just going to check that box, and it automatically marks it as the primary key. You mostly only ever use this as a primary key. Again, take the database class, but for our purposes, we're saying, hey, you go generate it, please, database. Do it for us. Okay, and then we're going to have a name for customer. So that'd be a variable number of characters. Names are probably a little shorter here. We could probably get away with 100. Very few people will probably have 100 characters, but that should give us plenty of space. And then what else we want to know about customers? We got an ID, we got a name. We could store address or phone number or email or anything else. We'll just we'll stick with name for now. So we just want those 2 fields. So if I click on Preview SQL, it's going to tell me this is the DDL, the data definition language. You say create table, name of the table, and then what field. So we're saying the ID field is an integer. It's not null. So null means you have to give it a value, but it will auto increment. And then name is a variable number of characters up to 100. Not null. You have to give it a name. Cool. We'll save. Okay. So now we have 2 tables. We have item, we have customer. Now I want to insert some data for customer. So I'm going to leave the ID blank. So if the field is auto increment, just leave it alone. I'm just going to give it a name here and put in Eric and say go. So it actually leaves a null value there, which is fine. It's not going to give it one. The database will generate one for you. So when I go to browse, I see ID is 1, name's Eric. Great. So now we have customer table. I'm going to go back and make another table now. So let's call this the transaction table. Transaction table has an ID. We're just going to let it auto increment. So I'm fond of calling it ID here. Depending on the database class you took, some database designers like the idea of every field essentially having the table name in it. I think that's awful. So I'm only ever going to call these things IDs. Yeah, KB. So we're gonna work on that, building out these tables for the lab exercise. So you can always follow along or watch the recording. that sort of thing. Like, you don't feel like you have to be clicking as I'm clicking here. We're going to have plenty of time tonight to go back and watch this video, and you can just follow along from there. But the goal is everyone will have this database set up, ready to go for next week when we're actually going to start writing some PHP code. And I'll give you, hey, here's one example for one of these things in PHP, and then you'll go do the next couple, is kind of the idea for these projects. Because that way, you don't have to do any database stuff on your own. You're just kind of following along for the database work, but then you're practicing, you're doing the coding portion of interacting with the database. So again, I'll just name them ID here. I think that's the easiest. Yeah, table1.table. Yeah, so I just call them ID. I'll click on auto increment here. So again, for transactions, we'll just let it generate a number. If I get more than 2 billion sales, fantastic. Again, I'm just going to kick that can down the road. It's not ideal, but we don't really care right now. And then what I need to do now, I need a way to identify the customer. So this is the customer underscore ID. Again, some people like underscores. We call this snake casing. That's what's pretty common in PHP and database land. Other people like the camel casing. I don't care one way or the other, just be consistent. But if you're going to follow along with me, it's all lowercase and snake cased with the underscores. So then customer ID is an integer because it's going to relate to the customer table. This will be my foreign key that relates to the customer ID and the customer table. Kebab casing. Is that, oh, that's dashes, right, instead of underscores? Okay. So we have the customer ID, and then what else do we need to know about transaction? We probably want to know what, the date and time, maybe? So we'll say date time or something. Date time. So this one we can pick then and say, hey, this one happens to be a, let's just go with date time here. The date time. So that's the date time of the transaction. Then other things we can do in here that might be useful, having the total of the transaction, like what was the total price of the transaction? We can always go calculate that later. And again, more database design sort of trade-offs here, or we could put it in this field. So I like that idea. So let's say the total cost, and we'll do that as a double here. So you give me the customer, you give me the date and time that their transaction was, and you give me the total cost of that transaction. Again, if you want to preview the SQL, you can see what it looks like here. And this is the data definition language. Awesome. I will save it. Now that I've saved it, now I can go in to the relationships and add that foreign key. So it doesn't happen automatically. So you got to go to this relation view. And we're going to say, okay, what's the relation? So in the transaction table, what column in the transaction table relates to another? So it's the customer ID. What database does it relate to? So you can actually have foreign keys across multiple databases, which is crazy. Most of the time it's in the same database, at least for our basic stuff that we're doing. So what table does it relate to? It relates to the customer table. What column? The ID column. So it automatically knew there was only one integer to match on here. So we're fine. You don't actually have to give it a constraint name. It will auto-generate it for you. And then these two dropdowns are super dangerous. I never recommend you change any of these ever. So the restrict is the correct option here. I don't even know why they include the other ones. This cascade option is the worst thing I've ever heard of, and it makes me cry as someone who works with databases all the time. So remember how we said databases will enforce referential integrity? Right? So I can't say this transaction belongs to customer 27 if there is no customer 27. Well, what onDelete does is if I go try and delete customer 27 out of the database, it will go and cascade that delete and remove all of their transactions. Oh, that's really, really, really bad, right? You don't want to do that. So restrict is the right action here. It will stop you from deleting customer 27 if there's a transaction related to customer 27, right? That's the appropriate thing. You don't want to go delete a ton of history and a ton of transactions. Bad stuff will happen, and you'll probably run into accounting fraud issues. If this was actually a store, and you're just like, oh no, we didn't have any of those transactions, they're all gone, because that'll be really hard to balance your books. So leave them on restrict. That is the appropriate action here. Again, more discussion in the database course. I'm sorry to keep doing that and doing this magic hand waving, but it's literally a 15-week course on databases here, and then some. So customer ID is my field. The customer table ID field is the foreign table and field that I'm relating to. I'll hit save. And here's the data definition language, the altering table, adding a foreign key, yada, yada, yada. And it just automatically calls it this thing here. Again, we don't care about the names. The names aren't all that important for, these are called constraints. Okay, so I've got item, I've got customer, I've got transaction, and now I need the line item in here. This is going to be my line item table. I might as well follow that along, right? Snake casing it, line item. So we're going to do an ID field, auto increment. Right? I don't care. This is fine. Again, if I sell 2 billion of them, fantastic. Then in here, I need an item ID as an integer, and I need a transaction ID as an integer. Transaction ID. Now, an important thing to know in the line item is how many of this thing did I buy, right? Quantity. How many of them did I buy? And then I need another column, so I need to go add a column, right? I'm going to hit add column here, add one column, and then I'm going to have, this is total, I don't know what, what's total cost, that's fine. So the cost of this quantity at that point in time. So remember, because databases we have this idea of things being referential, and we can always point back to where they exist in the table. If you sell Coke today for $1.99, and next week you say, oops, we need to raise prices because of inflation, and you put it up at $2.09, none of your line items will have that correct pricing, right? Because they're saying, oh, what was the price of it when they bought it? Well, right now it says Coke Zero costs $2.09. So we need to store what the cost was at that point in time so we can go back and get the right value back out. Okay? So this is an important thing to have in here for making sure we're following along and getting current information so that if I go and update an item later, I don't update all of their line items. Okay, we'll save that one. And then I can go to the relation view here, and I can go add those foreign keys. So the first one then, right, what column here? I have an item ID, relates to the item table. Oh, sorry, it's SKU. I should have called that SKU. Hang on, let me go back. We got to change that. So it's the item SKU, not an item ID. So I'm going to change this table here, this column here, to item SKU. That's right. And just save, and that should fix it. Okay, so now it's item SKU. Now I'm happier. I want them to match. They don't have to match, but I think it'll make more sense if they match. So the item SKU column relates to the item table SKU column with restrictions, right? And then another one now, the transaction ID relates to the transaction table ID field. We'll save that one. Okay, so now we have 2 foreign keys. So any line item then will reference one particular item and one particular transaction. So if you're going to buy 10 things, you'll have 10 line items for a single transaction for a single customer, which is perfectly fine. That's how we want this sort of data to relate. Okay? So adding information here is going to be a little bit trickier, right? Because I have customer, right? I've got customer Eric, and I have items. We have coffee. So to add a transaction then, we're going to go insert a transaction. Now, the PHPMyAdmin tool is amazing. It knows, hey, this is a date time. Pick a date time. Go for it. And it defaults it to right now, which is good. The customer ID, it even gives you a drop down to say, oh, here's the customer primary key, and here's the other information about it. So it shows me, hey, this is customer ID 1. By the way, that's Eric. Right? So we're not actually storing Eric. We're storing the integer value of 1 here. For transactions, it's an auto increment, so we're going to leave this alone. And then the total cost here. So when we sell stuff, this would be the total cost of all of the line items. Again, it's calculatable. Excuse me. So there's trade-offs, reasons why this is good, reasons why this is bad. That's fine. I'm going to say, sure, it's $1. Because I'm going to buy 1 coffee in a second. So we'll say go. And it says, hey, this is insert into transaction, and given an ID, a customer, a date, time, and a total cost. Values of null for the ID, because it's auto-generated. 1 for the customer ID that relates to Eric. Here's the date and time. It's a big, long string that if it gets converted here, makes life pretty easy. And then 1 for the total cost. Now I'm going to go to line item. Now I have a transaction ID, so I can insert into here. The ID of this one will auto-increment. The item SKU is coffee. The transaction ID is 1. The quantity is 1. And then the total cost is 1. So buying one coffee should cost me $1, right? And if I only buy one thing in this transaction, there's only one line item. If I want to go buy more things, then I can go add more things. All right, I'm feeling bad about transaction. I think maybe we'll get rid of total cost, because we'll just go calculate that. When we start looking at some more SQL, we can do that after. So I'm going to say drop this field here. I'm changing my mind on it. We'll get rid of it. So just the ID of the transaction, the customer ID, and the date and time. We'll let the line item be the total for all of that stuff. Because otherwise, if I go change my mind and say, hey, I wanted to buy another thing, the proper thing would be make a new transaction, but now we can just make another line item, that sort of thing. So this one looks really boring. It's 1111111 because it's not the most interesting field here, but our coffee costs $1. So what we'd have to do in the programming side of things, we would go look up these values and say, hey, how much are you buying? Oh, okay, you want to buy 10 of these things? Okay, so 10 times the price, right? We'll go add that in, and then our line item would be 10 times the price. And we could store the total cost. All this would kind of just fall into place here as we're going. So we'd have to use some data manipulation language to get values out, to select them, so that I know what I'm going to go insert or create in the other tables. But this is a very basic setup now for our little database here, and now we can start building a store. Right, so I can start building the web side of things, the web interface for what we can do now to start, okay, here's the list of items that we sell. How many do you want to buy? We could pretend to have all sorts of payment processing sort of nonsense. Again, payments are hard. That's why there's all sorts of cool vendors. I think Stripe is a really popular one, and one of my favorite profs from my undergrad actually is one of the engineering managers at Stripe now, which is pretty cool. Hey, thanks so much for coming along, Lizzie. All right, so we've got our database set up here then, and give me just half a second. I want to make sure we're covering all of our bases here. So for our lab assignment, well, let me show you one last thing here. So what we're going to do then, once your database is created, you go back to the database itself and click on the database here. You got this really cool export button. Export is going to give us a bunch of SQL that will essentially recreate everything. So if our format is SQL, right, we want everything here, it's going to give us all of the DDL for the tables and all of the DML to insert all of the files. So if I just open this up real quick, let's see what, I don't even know what tool that's opening it. I don't want to open it with that. It's probably opening my Microsoft SQL Server tool, and I don't want that. Let's just take store here, and let's say open with, let's do VS Code is probably better. VS Code will be nice and quick, because that other tool is still thinking about opening. It's not the lightest weight tool. So what I get here is the SQL, and we see, oh, hey, it came from PHPMyAdmin, has all sorts of cool stuff here. And then here's the tables. Here's the customer table and the data for customer. Here's the item table, the info for item. Here's the line item table, the info for line item. Here's the transaction table. Here's the info for transaction. So as you add more and more and more and more data, right, you'll get more of these insert statements. We only did one. After it adds all the data, then it goes and adds all the keys, because to make sure that we're doing it in the right order. Hey, thanks so much for coming along, the Reluctant Hermit, my friend. Folks, the Reluctant Hermit is such a nice person. Definitely worth your time to go and hang out with him. Always ready to cheer you up and have a good time in his stream. Definitely a streaming hero of mine. So I think I know how to do this shout out thing, if I can spell your name right, because copy paste is hard. Look at that. Let's see if my bot command works. It does work. It does work. So thanks for coming along. So our export here then, right, has all of these alter commands. Adds them all. Yeah, okay, here's my other tool finally. This SQL Server Management Studio. Wow, you're so slow. So this is a single export then, a single file. What we can do with this file then is I can go drop this in my repository. And you could actually take all of this over in SQL Server. Now, I don't recommend you do this because it's good to go through the steps, but you can go and make a database, and then you go to this little SQL tab, and you can copy paste it all in. I can just grab it all here, put it all in here, and hit run. Now, mine isn't going to work because I already have these tables, but if you made a brand new database, you could just copy paste this whole thing in here, and then it'll make it all for you. So it's a good way to kind of it's not an actual database backup, but it's a quick, for us, for our purposes, to get things saved for us, to export that out. There are actual ways of doing real database backups, that sort of thing. This is just, here's an export, here's a dump of everything, just in plain text format. So it's not the most efficient or anything, but it's a nice, easy way for us to do this. So what we're going to do for our lab is you're going to go through and build this database out and export it, and then you can commit this file. You can probably just submit the file, actually. That'll be just as easy, instead of putting it in source control. And then you can just give me that file back, and I can look at it and make sure you got everything that looks right, that sort of thing. So if you've got it, great. So I won't actually commit this or anything. If you're having trouble later, maybe next week, after we've talked about the lab, I can give this out, and you folks can just go run it if you want. But you should go through that practice of building it out yourself, working with the tool, doing all the clicking and dragging and dropping and stuff. Let me just close this out. It's good practice. So we're going to do this store database for all of our examples, for the first portion. And then when we get to our final project, I'll help you with the final project database as well. I'll kind of build that out and give you an export here that you can work with if you want. Because that's kind of how we're going to work around you not having a database class as a prerequisite. So I'm happy to do some of that database work for you. And then next week, when we get into actually writing the commands to do those sorts of things, I'll help you out with those as well if you get stuck on anything. Because what we're essentially going to do, so all those things where we had, cancel, okay to leave the page. When it does like these select commands or all the inserts, we're going to essentially take these strings and put them into code. No, I don't think we need to commit it to GitHub right now. I think there's not really a whole lot of gain for doing that, goat. Later, maybe. So for sure, when we work on the final project, if we're going to do this with a partner, it's really nice to have that in your source control. So if one partner built it, then the other partner can go and run it. And then if you ever do need to make changes, you can export it all out, drop it back into source control. But for us, just our individual ones, I think will be fine. You can just add the project for me. So let me go put that in as the lab. And that's essentially it for today for a blitz through relational database management systems and MySQL. There's a lot more to it. Definitely go read the chapter. There's a lot of good information there. Don't feel like you need to memorize any of it. The goal here is we kind of understand the general structure of, hey, this table, right, is going to store this information, and then it will relate to another table that stores this information, relates to another table that stores this. So we're going to practice kind of navigating around those here as we go. So this is lab 2. This is our SQL, or MySQL, right? MySQL database. So we're going to create the store database, and then export it as a SQL file and submit that. So let's just say, please follow along with the class recording. So just upload a file. This will be in our labs here. So not a ton of homework here, hopefully, for you. Again, it might take a little while of clicking back and forth, following along here. So we want to get this one done and out of the way so that next week we're ready to actually start writing PHP code. So you'll have a little bit of extra time to finish up Project 0 here, which is good. So I've got the rest of the night to hang around, do screen sharing sessions, jump in, answer questions, whatever. I think 1 or 2 people wanted to meet with me. You were having some trouble with Lab 1, and I just wasn't able to help today, unfortunately, because Thursday is the busy day. So I'm going to meet with a couple people after class. If you have other questions, happy to put you in the line there, and I'll just bounce around. We can either do Zoom or we can do Discord, whatever works well for you. I'm fine with. Just let me know, send me a message. So I'm either going to be in Discord or text messages or chat, and we can go from there. Marv, thank you. That's such a great emote. I like that. Purple's my daughter's favorite color. She'd be so thrilled. Is purple like the default color for the hearts? That's so cool. All right, so take the rest of the night, make sure SQL starts up, get to the PHPMyAdmin page, build those tables, add the foreign keys, those sorts of things. Get working on Project 0. Again, please, if you have questions about it, send me the questions right away. Happy to hop on, get you pointed in the right direction here. If you wait until next Thursday to start, I have very limited options to be able to help you get up and running. So, let me know. Happy to meet off the regular office hours, if that's what works best for you. Shoot me a couple possible times, and I can see if one of those might work for my schedule. So we can do that, okay? All right, so I'll go ahead and end the stream here. Let me put on the ending title here. I don't know if there's anyone else we want to go raid in Twitch land for fun, but maybe we do. That's always part of the fun of Twitch, is we can go out and raid some silly people. We'll see who's around. You know anybody who's around, Hermit? You still around? Anybody should go send a raid off to for fun? Let's see, who's around? My friend Bjorn is playing Kingdom Hearts, if anyone wants to watch Kingdom Hearts. Or there's Owen doing woodcraft work. It's fun. We got paleontologizing, if you're interested in dinosaurs. He's a really cool paleontologist that streams. Or there's also chess, if you folks are interested in chess. Got lots of options. Alright, if we don't have any votes, we'll just send one off here. Let's go raid, how about paleontologizing? Dinosaurs are always fun, I think. Hopefully I spelled that right. Yep, so we'll head over that way, say hi or drop off, no big deal. It's just part of the fun. And we can go from there. Alright, dinos, I like it. I like it, we'll go with dinos. See you folks around.